Now we're going to do the factors affecting solubility part 3. Okay, this is where we're going to see how surface area affects solubility. And so I've got equal amounts of water in 3 different test tubes here. And I've got 0.2 grams of powdered salt, regular salt, and rock salt. So let's see what happens. Let's start out with the rock salt first. So I'm going to take it, pour it in here, put the lid on, see how many inversions it takes, just like we've done before. If it takes more than 25, we're not going to count them. We're just going to stop at 25. So that's 1. You can see there's salt still on the bottom. There's 2. Still salt in the bottom. There's 3. 4. 5. 6. 7. 8. You can still see the particles of salt down here. 9. 10. 11. 12. 13. 14. 15, 16, 'let's say it takes about 16 to get the rock salt dissolved. So in your data table for rock salt, put 16. Then we're going to do regular salt. We know it takes between, the first test was 3. The second test was, I think 4 inversions. So we'll do the same thing. Pour it in. Let it settle to the bottom. Let's count the inversions here. So 1, 2, 3, 4 is what I got this time for the regular salt. So back over to your table. For salt crystals, put 4. And then we'll do powdered salt. So I have, again, 0.2 grams of powdered salt. We'll pour it in. Take the lid off one of these. We'll invert it. And it only took 1. Okay, so you'll put 1 here for powdered salt. Now let's talk about this real quick. The question is, how does surface area affect solubility? If you look at a piece of rock salt, I always have people say that rock salt has a larger surface area than powdered salt. And if you then take an equal amount of powdered salt so look at the piece of rock salt and look at the powdered salt here. Which one has more surface? Well, you can definitely spread out the powdered salt a lot more. So the powdered salt has much more surface area than an equal sized piece of rock salt. So that's why powdered salt has more surface area. Rock salt would have the least surface area.